So picking up where we left off yesterday, let's take a look at number 30 here. Find the derivative of the function. All right, on number 30, I've got a quantity with an exponent on it. So we can use the chain rule to find the derivative of a quantity with an exponent on it. In fact, we can use the general power rule version of the chain rule. Okay? We've got u to the n, so the general power rule says that the derivative with respect to x of u to the n is n times u to the n minus 1 times, and what always comes at the tail end of the chain rule, times the derivative of u. All right, so that's the way we're going to approach this. So f prime of, or h prime of t instead of f prime of x will equal. All right, so exponent times coefficient. Exponent of 2 times the coefficient of 1. 2. U, so that entire quantity, that whole thing inside the parentheses is u. T squared over t cubed plus 2. Subtract 1 from the exponent. 2 minus 1 is 1, so the new exponent's 1. So we did that, we did that, we did that. Now, times the derivative of u. Well, t squared over t cubed plus 2 is a quotient. So to take the derivative of u, I have to use the quotient rule. We'll talk about that in just a second. All right, so the bottom, t cubed plus 2, times the derivative of the top. Derivative of t squared is 2t, minus the top, so minus t squared, times the derivative of the bottom. The derivative of t cubed is 3t squared. The derivative of 2 is nothing, so it's just 3t squared over bottom, t cubed plus 2 squared. And now we've done that. Yes?
I got this now because I did my homework and I realized that I was like doing it wrong. But why wouldn't you just put 1 for c?
I don't know what you mean.
You know, like when it's like c plus 2 would be like 1 plus 0.
Because it's a t cubed.
Okay, so you just.
So like if we were taking the derivative, if that was u, when we took the derivative of u, we would get 1. But since it's that, the derivative of that, the derivative of t cubed is 3t squared. All right? Okay. Now, remember the original version of the chain rule. And we can do the simplification from here. Sometimes it's really difficult to simplify from here. Sometimes not so much. We'll see how this one works out. But I want you to keep remembering what the original chain rule, the actual chain rule says. It says that the derivative is of f of x when f is a function of, when it's, you remember how it all goes, all right? That times that. Well, I can see how the du dx and the du dx are the same. Can you see that that is that? Let me show you how it is. If h of t, well, it'd be h of u, was just u to the second, wouldn't its derivative be 2u to the 1? Isn't that what this is? 2u to the 1? Okay? So you see how the n times u to the n minus 1 is the dy du from the original chain rule. I'm emphasizing this because later on it's going to be really important that we remember the original chain rule. Okay? Most of the time now, the general power rule will get us what we need most of the time. It's going to be vital once we get to the fundamental theorem of calculus that we remember the original chain rule and that we know that it works, the dy du times du dx. Okay? So I've seen the potential problems and I'm trying to head them off as best I can. Okay? All right, so here we are. Now we got to simplify. So let's leave. Let's leave. Let's work with the denominator first because that's the easiest part. If I've got a t cubed plus 2 times a t cubed plus 2 quantity squared, hadn't I might as well call that a t cubed plus 2 quantity cubed? Now, I've always told you, don't bother multiplying the denominators out. And I don't really feel like I did multiply the denominator out. I just made it one quantity instead of two quantities because they were the same quantity. Okay? So I'm still leaving the denominator factored. It's just a little nicer form of factored. So I've taken care of that. Everything else is in the numerator. So 2 times t squared is 2t squared. And then here, it's going to take me a couple steps. So I need to distribute the 2t times t cubed and get 2t to the fourth, and 2t times 2 and get 4t. And then I need to multiply negative t squared times 3t squared and get negative 3t to the fourth. Make sense? All right, so we're good to there. Okay. All right, well, let's see. What else can I do here? I've got the 2t squared. I'm happy with that. But inside the parentheses, I do have like terms I can combine. 2t to the fourth and a negative 3t to the fourth is a negative t to the fourth. And I still have the plus 4t. And what do you think? What else can we do? Take out another t. So in the numerator, if I factor out a t from the parentheses, that'll be another factor of t in front of the parentheses. So instead of t squared, well, instead of t squared times t, I can write t cubed, correct? And then negative t to the fourth divided by t is negative t cubed. And 4t divided by t is 4. Are we happy with this? Yeah, I think so. The only other thing I would consider doing is factoring a negative out of the parentheses just because it seems a little awkward to have the first term in a parentheses negative. But it's not going to make me be able to divide anything out, is it? So I'm good. And that's how you do that. It's not terrible. It's kind of daunting when you realize that you have the quotient rule inside of the chain rule. Okay, it gets a little scary. It's okay to be scared. You know, keep the lights on when you're doing your homework. Yeah. There's all kinds. Now that we have product rule, quotient rule, chain rule, you'll see that pretty much any combination of one of these inside of another is possible. And they're all a little scary. Yeah.
Can you explain how you got 2t to the cube on the left?
Yeah, I did this. I had the 2t squared. And then from my parentheses, I factored out a t to give me then t to the fourth. Negative t to the fourth divided by t is negative t cubed. 4t divided by t is 4. So I just skipped the step of writing that because then I multiplied that together. Okay? All right, now, there are other ways we could have worked this problem. And you never know if the way you choose is the best way until you've done it. And then you might think, wow, there's got to be a better way. Well, but you've already done it. You really going to go back and redo the problem? You can if you want. I mean, if you've just got all the time in the world to keep working the same problem 7, 8 times, you go right ahead. But look, here's some things we could have done. We could have rewritten this function. We could have made it the numerator squared over the denominator squared and quotient ruled it there. Now, if I quotient rule it there, when I take the derivative of the denominator, I got to use the chain rule on it. Right? So I could avoid that by actually doing that, and that'd be what? T to the 6th plus 2t cubed plus 4. Now that's just a plain old quotient rule problem. Okay? Thing is, that's going to be the answer in the back of the book, and you're never going to see that your answer is equivalent to it. So you're going to rework it you're going to do that one 7 or 8 times because I never get the answer in the back of the book. It's not wrong. It'd be fine. You can do that. Okay? But the thing is, don't be afraid of doing the problems with a rule inside of a rule. Okay? Because it's one of these, the law of unintended consequences. If you make part of the problem simpler, what have you almost certainly done? Made another part of the problem more difficult. Okay? Because, look, taking the derivative of that is going to be simpler. But factoring it, which is essential later on, it's a must later on. But once we get that, factoring it to get what I have at the end of this problem is going to be extremely difficult. Okay? So, there's no free ride. There's no free lunch. You're going to pay one way or another. All right? Yep. Once we're sitting here with the t to the 4th, because surely we'll change that to a t to the 4th, all right? Over t cubed plus 2 squared. I still haven't done any calculus. I can change that to t cubed plus 2 to the negative 2. Now I can do the product rule, right? That's the first function, that's the second. But when I take the derivative of that second function, what will I have to use? The chain rule. And I'll end up with a negative exponent in my answer. And do I leave negative exponents in my answer? So I'll have to go through a whole big process of getting rid of that negative exponent. I mean, look, here's what I would do. If that's my h of t, what I would do next, I'll say h prime of t equals the first function times the derivative of the second. That'd be negative 2 times t cubed plus 2 to the negative 3 times the derivative of u. All right? That's the first function times the derivative of the second, plus the second function times the derivative of the first. And there's nothing wrong with that. Now you got to simplify it and get this. Okay? I don't know how you can avoid it. What do you want to do? There's not a product chain rule. There's a product rule, there's a chain rule. You can have one side the other.
Could you just not do negative 2 times 2 to the 4? Leave the parentheses the same, and then take the derivative of t cubed plus 2.
Nope, you cannot just ignore the product rule because you want to. And that's not what you're meaning to do, but that's what you're doing. Okay? It'd be nice. So I'd have t to the fourth times t to the sixth plus 2t cubed plus 4 to the negative 1. Yep. It'd be the but once we've written it like that, now we've got a product rule with the chain rule when we take the derivative of that second function. That's what it is. We don't avoid it. The way I worked it originally was the chain rule was my first one. The quotient rule was inside of it. You're going to have two rules. There's no way to avoid it, is there? Okay, we can rewrite it. We can prefer one method to another. But this is a fairly complicated function. There's no way around it. Okay, which version of what I've got written are we talking about? Here? All right, because if I take the derivative of that, ugh. Let's not cry. There's no crying in calculus. So, if I take the derivative of that, if that's h of t, I got to product rule it. First function times the derivative of the second. To take the derivative of a quantity with an exponent on it, okay, if I went up here to the black one, what do you want me to do? Quotient rule? I can quotient rule that. No, but look what I get. You're right, I don't. I can narrow it down to one rule there, you're right. But I'd get the bottom times the derivative of the top.
But for someone like me that doesn't know the chain rule yet.
Yeah, you see where it's going? Okay, so you did. You came up with a method to avoid using two rules. Yay! Yeah, it looks. I'm not looking forward to that factoring. No, you're better off learning the chain rule.
Yeah. So to actually be able to use the chain rule, you cannot. There can't be a something multiplied by the quotient multiplied by the quantity.
I'm not sure I follow you. Let's go on to the next one. We can come back. Number 52. The directions still say, find the derivative. G of t equals 5 times cosine squared of pi t. All right, now, we just got through talking about quotient rule inside of a chain rule or chain rule inside of a product rule. On this one, we get to have the chain rule inside of the chain rule. That's exciting. All right, because the cosine squared notation means means cosine of pi t squared. Those are equivalent. You've got to understand that notation, okay? That'll cause people grief too if you don't understand the trig notation. Because if you don't, it won't work. How do I know if I don't, it won't work? Because what's the chain rule called? It's called a theorem. It has been proven that this is the way it's done.
I mean, like, I get that it works. I think you should do that.
Why? Because it's been proven that this is the only method that works. All right, look, your argument's not with me. It's with him.
He's dead. Can't argue back.
Well, I mean, you know. Oh, you can win an argument with a dead guy if you're right. But Newton's right.
Why isn't that just like, why isn't that just 10 cosine pi t? Why would that not work?
Why would it work? Why isn't the derivative of everything 2? And think how easy this class would be if the derivative of everything was 2. So see, we'd be done. We'd be studying for the AP already. We would have covered all of our subjects, and we'd practice this. This would be our AP test prep. Do it again. Again.
You didn't make the list big enough.
They're like, oh, then one of you would do that. No! I don't have a better answer other than, you know, why is the door called a door? Because that's what we call it. Well, why is the derivative done this way? Because that's what works. I don't have a better answer. I did not invent calculus. But I do trust Newton. I trust him with my calculus life. Alex.
That's what I'm talking about right there. Just go on.
You want to do what Charlie wants to do? And make that 10 cosine of pi t and move on?
Dude, that's what I want to do. So bad.
Then the derivative of the,
That's what we're going to do. Yeah, this is a real short problem. Okay, hang on. By the way, anytime you just want to miss them all, feel free. I mean, you know, your grade's going to be really, really bad. But if you just want to miss them all, go ahead.
Can we have Stefan the ghost of
No, because he would laugh at us for having trouble with this. He'd be like, morons.
Is it because since the derivative is the slope of the tangent, then to get the slope of the tangent, you have to do that other way. 10 cosine pi.
Yeah, that just simply won't give you the right answer. All right, so look, we're on to something here with this. Believe it or not, we're really on to something there. Isn't that what we ought to do to start?
Yeah.
This is the general power rule. Okay? So, close your eyes. All right, open your eyes. So we really do. N times the coefficient, 5 times 2, u, cosine of pi t, subtract 1 from the exponent, 2 minus 1 is 1, then the chain rule part, times the derivative of u. So now we have to take the derivative of the cosine of pi t. Okay, everybody ready to take the derivative of the cosine of pi t? Let me erase all this other stuff. Look, here's what we got to do. We've got the cosine of pi t, and we're going to take its derivative. I have to chain rule that. Because isn't that the derivative of the cosine of u? It is. It's not an x. It's not just a t. It's a pi t. We're going to have a pi t. All right. So, the derivative of the cosine of u is negative sine of u times the derivative of u. And what's the derivative of pi t? It's pi.
Oh my God.
It's only barely witchcraft.
Do what?
It's only barely witchcraft.
Yeah. Where'd I confuse you?
have to make a chain rule?
All right, because if I didn't, if I just wrote negative, if it was, let me phrase it this way. If the pi was not there, and it was just the cosine of t, the derivative would be negative sine of t. But since it's not just t, it's something else. Since it's something else, that something else has to be the u. That has to be the other function, okay, that makes it into a composite. So I can squeeze that in there, but what's always at the end of the chain rule? Times the derivative of u.
Oh.
What is this supposed to use?
U is a function of, in this case, t. So that's u. All right. Anything, look, anything besides just x, or in this case, just t, has to be u. You can't treat something that's not just t as if it were just t. Does that help?
Yeah.
To think of it that way?
Why do you have cosine pi t times negative sine pi t? This is not
All right. It was your idea. You have to understand your own idea. All right, so look, I'll just get rid of all that. Let's mentally. You need to be able to do this mentally. You know what the cosine or notation means.
Yeah, I can do that.
We know it's that. So we're going to use the general power rule. The general power rule says that the derivative of u to the n, where u is a function of x, equals n times u to the n minus 1 times the derivative of u. So that's what we're doing. So g prime of t is going to equal 2 times 5. All right, that's the n time, that's the exponent times coefficient, times u cosine of pi t to the n minus 1, 2 minus 1 is 1, times the derivative of u. So all the rest of this is the derivative of u. That's u. That's our first u, right? So now I've got to take the derivative of the cosine of pi t. To take the derivative of the cosine of pi t, according to what we learned yesterday, the derivative of the cosine of pi t will be negative sine of pi t times the derivative of pi t, which is pi. So our original u is this. Our chain rule inside a chain rule, u is this. That's why it's a chain rule inside of a chain rule.
The chain rule is like a function of a. I'm trying to figure out why we don't have to be
Because it's not just t.
there's like another like
If it's anything besides just t,
like squared unit two.
yep, got to chain rule it.
Oh.
So our final answer
Like with the kind of
all right. New problem. We had g of t equals 5 times cosine squared of t. Mentally, we would think of that as the cosine of t squared. So g prime of t would be general power rule, exponent times coefficient. U is the cosine of t, so u, subtract 1, subtract 1 from the exponent, So now it's a 1. And now times the derivative of u. Okay? That's it. All right, we getting somewhere?
Really? Let's stare at it.
Yeah, all you got to do is stare at it and boom, it's in your head. 65. Evaluate the derivative of the function at the given point. So first we find the derivative of y equals 37 minus secant cubed of 2x. Then we'll evaluate it at the point 0, 36. All right, before we get started, what's the derivative of the secant of x?
It is. It times tangent.
It's the secant of x
Tangent.
times the tangent of x, correct? All right. What's the derivative of the secant of u? But not x. Secant of u times the tangent of u times the derivative of u. However you want to write it. U prime du dx. Okay? All right, so number 65. We want to take the derivative of y equals 37 minus secant cubed of 2x. Secant cubed of 2x means the secant of 2x in a parentheses with an exponent of 3 on it, right? What's the derivative of 37? 0. So we start off good. Don't look. All right, now, minus secant cubed of 2x, so negative, okay? Now, isn't that u to the n, right? If u is the secant of 2x, that's u to the third, isn't it? The derivative of u to the third will be 3 u secant of 2x, subtract 1 from the exponent, 3 minus 1 is 2. So what I have so far is I have n times u to the n minus 1. That's what I have showing so far, because you're not looking ahead at that, are you? That's n times u to the n minus 1. That's what I've got. What's the end of the chain rule? Times the derivative of u. What's u? When I said that was u cubed, what was u?
Negative
Secant of 2x, right? Secant of 2x. So now I've got to take the derivative of the secant of 2x. You with me? How do I find the derivative of the secant of 2x? By using that. The derivative of the secant of 2x will be, according to this rule right there, the secant of 2x times the tangent of 2x times the derivative of 2x.
Okay. Question. Why is u not secant?
Because it's just not. What quantity is raised to an exponent? It's the secant of 2x that's raised to an exponent. So that's u.
Okay.
Now, everybody follow me. Once I'm to this step where I need to take the derivative of u, that means the derivative of the secant of 2x, doesn't it? So, whole new problem, really. The derivative of the secant of 2x. Now what am I considering to be u? Now 2x is the u. So, secant of u, tangent of u, derivative of u. This is kind of key that we get, or kind of, can it be kind of key? This is a big deal. Okay, so you guys with me? All right, let's see. 2 times negative 3 is a negative 6. A secant squared of 2x times a secant of 2x would be secant cubed of 2x times the tangent of 2x. All right, so if all we had to do was find the derivative, we would be finished.
Right.
Questions? That's it for the derivative. Not it for the problem. Because it said to evaluate the derivative at the given point. Well, the point is 0, 36. Does the 36 have anything to do with evaluating this? No. Later on, we'll have derivatives with y in them. That's why they keep giving us the whole point. Okay? But I need to replace x with 0. So y prime of 0 equals, we're not even going to need we're not going to need your calculator. Because look, I can't evaluate that with or without a calculator as it's written. Can you? I need to change secant to 1 over cosine. So, see, I just copied down the negative 6, and then instead of secant cubed 2x, I made it 1 over cosine cubed 2x. Right? Because secant is 1 over cosine, so secant cubed is 1 over cosine cubed. And then tangent, I could do tangent, I guess, but I went ahead and changed that to the sine of 2x over the cosine of 2x. So if x is 0, right, at the point 0, 36, if x is 0, that would be negative 6 times the sine of 0 over cosine to the 4th of 0. See how I got the cosine to the 4th? Cosine cubed times cosine to the 4th. And, 2 times 0 is 0. What is the sine of 0? 0. What's the cosine of 0? That was fun. No fun? So wait a minute, let me get this straight. When you guys are at home on a Saturday night, you don't get the calculus book out just for fun? Okay. When you're cruising the square on Saturday night, there's not somebody in the back with a calculus book shouting out derivatives to you.
Well, that's actually the kind of music we got from.
Well, it's math. It's got to be better than others. All right, so add this to your list of problems to do.